Questions. All right, next we have Aayushi Verma, who is a data science fellow at the Institute for Defense Analyses.
Okay, good afternoon, everyone. It is a pleasure to be here. So this is a project that my colleague and I have been working on for some time, and I thought I'd take this opportunity to share with you some of the results that we have obtained, preliminary. So we are a research institution, and we are constantly producing a lot of research. So in the data set that we obtained for this analysis, we found out that over the last few years, on average, we are producing 113.4 research reports every year. And upon some further analysis, we found out that 96% of these research documents are PDF formats with an average number of 70.84 pages per document. So also, we have developed our own set of taxonomies and across each of these 8 categories. And these are an organized hierarchy of keywords that describe the research being done across those areas. So the question that we're trying to answer here is, how can we quickly tag our research documents with terms from the taxonomies in order to create what we call as tagged products? Just so to add some context, our researchers currently have to manually tag their documents themselves. So obviously this is a very laborious and time-intensive process, and that takes away from, the researcher's job, which is to do research. And although this does create a nice tagged data set, it comes at the expense of quality. So, considering questions like, have all of the researchers tagged the documents consistently? But also we need to consider things like periodicity. We currently have to make our researchers tag their documents periodically every few months. And so if you're publishing a research document within that gap, then your document is not going to get tagged with terms from the taxonomies. So to address this challenge, we have developed a capability to automatically tag these documents using natural language processing methods. So just to visualize what exactly that means, on the left here, we have our average, research document produced every year with an average of 70.84 pages per document, right? And so that is a lot of text, pages and pages and pages of text. What we have done is effectively boiled down that long document into a set of keywords that describe the content of that research. So, at a quick glance, you can tell that this document is roughly talking about things like data management, data science, R, data visualization, so on and so forth. So this is the pipeline that we have implemented in Python. I'm not going to go through all of the details, but please come find me during my poster presentation. I'll talk about all the details you want. But the idea is that we ingest our PDF files, we extract the text from them, we clean this text, we obtain what's known as TF-IDF importance scores, which is effectively looking at how important the extracted keywords are relative to their frequency across all of the documents. We filter this list of extracted keywords using our taxonomies, we perform some quality checks, and then finally we write this data set of products, their tags, and their importance scores to a database for some further analysis. So just to visualize what exactly that means, here is a test document, and this is the top 25 terms returned by the pipeline. And at a very quick glance, you can very quickly see that there are terms like Mars, space, March, lunar, exploration, that are very important, that show up the most frequently in this document. And so you can very quickly tell what this document is likely about, talking about the space domain, talking about Mars, lunar exploration, things like that. So that is our preliminary, those are our preliminary results. We have found out that, being able to extract those keywords from text, it's actually a pretty trivial task. Anyone can do it. But in order to get the quality in the data set that we're looking for, we need to consider some more important questions and quality checks. So that's looking at questions like, does this set of tags accurately reflect that body of work? Will a human tag the document similarly as the pipeline? Is the tagging process consistent across different areas of research? And finally, how do we consider the context, the ambiguity Basically, how do we consider, the semantics of the English language? So the idea is that through this pipeline, we are able to present a sort of base set of terms that a human can just simply verify. So this drastically cuts down on the time needed for humans to physically tag their documents. Instead, now they are just presented with these automatically generated terms, and with this human in the loop interaction, they can add things that may have been missed. They can remove things that should not have been there. But yeah, the idea is to save some of the time. So something that I did not address explicitly yet is why are we even tagging products? What benefit are we gaining from that? And the idea is that once we have a product and we're generating these set of keywords, this is generating metadata for that product. And when we combine this metadata with other details about the product, for example, its authors, people, the divisions of the authors, maybe even sponsor information, we effectively gain this very rich and powerful data set from which we're able to characterize and quantify the research that we do here. Again, adding some more context to that, this is one of many projects as part of our company's data strategy. And we are working on developing a lot more data-centric capabilities and systems to propel ourselves in a more data-centric manner, using things like using principles like data management and data governance. So here are some of the references. Thank you.